Okay, looks like we're back for another day. I'm kind of looking forward. I'm actually feeling pretty tired from this whole day. Just been doing a whole lot of other work, so I don't know how on top of solving challenges I'm gonna be today. But we'll see how that goes. So looks like we're at about 4 minutes to go. So let's see what's happen. What's gonna happen when that comes on. My computer's actually lagging quite a bit. I'm gonna stop the stream. I'm gonna see if I can fix this. Give me a sec. Okay, testing. Let's see if this works again. All right, so I'm pretty glad I got this sorted right before it starts. Really sorry about that. I've just switched some things around. Anyway, the challenge is about to start. So let's see how we go this day. So I lost my boarding pass. So we're gonna try and find my seat through elimination. The first 7 characters will be FOBs by exactly one of 128 rows on the plane. Exactly one of the. The letter tells you which half of the region the given seat is in. Ah, okay. Consider the first 7 characters of this. 1, 2, 3, 4, 5, 6, 7. Right. So F means the lower half, so say there, B. Oh, there must be a better way to do this. All right, I'm just gonna try something really fast here. I feel like we could just convert I feel like we could just convert this to binary and we would get the number we want. 44. No, the other way around, right? Yeah. The last 3 characters we've left, right, is exactly one of 8 columns, numbered 0 to 7. Right, left, right. Okay, let's try this thing. Right is lower half is left, so 101, column 5. So decoding that reveals that every seat has unique seat ID. Multiply the row by 8, then add the column. In this case, the seat ID is that. Here are some. Wait a second, isn't that just. Wait, I think they're being sneaky here. Isn't that just 0, 1, 0, 1, 1, 0, 0, 1, 0, 1? Yes, it is. Here's some, so look, go through a list of boarding passes. What is the highest seat ID on the boarding pass? Seat ID, right? Okay. Well, that's a very simple challenge once we've it's a very long-winded way of basically saying that these are actually binary numbers, but so input.map, we want to replace, give me one of these. Oops. Dot replace if L with 1, no, if with 1. Oh, I need, you know what? I'll do it like this since regex uString. Only the first occurrence will be replaced. Isn't that annoying? Include G in the regex. All right, so apparently we need to do something like this. If, what is it? If and L are zeros, and these and rights are ones. Right? I should have done this with the original, or with the example one, because yeah, there we go. That is it. I will explain that in a second. Oops. We're not trying to convert the same thing every time, right? Cool. And we just want the biggest number. So numbers.sort. JavaScript sort has a really weird thing where the default behavior is wrong for sorting numbers. Cool. We'll sort backwards, and we'll take the first number, 806. 300th. That's okay. We're improving. All right, ding, the fastest seatbelt sign is on. Time to find your seat. It's fully complete, so each seat should only be missing boarding passes on your list. Here's a catch. Some of the seats at the front and back don't exist, so they'll be missing from your list as well. Your seat wasn't at the very front or back, though. The seats with IDs 1, +1, or -1 from yours will be in your list. What is the ID of your seat? So there's a missing number somewhere in the middle of this array. What's the easiest way to find a missing number in the middle of this array? What's the smallest number in this array, actually? $49. Okay, so -49. Okay, so we'll do something like this. This is a silly way to do it, but I can't think of anything off the top of my head. It's been a long day. So I'm just going to compare the number in the list to the index. And I'm not sure, I don't trust myself to do this right, so I'm just going to do it like this. Right, this has to be the first time only. 562 is the missing number. 204. Oh man, this was actually quite an easy challenge, but I unfortunately am completely fried. I've fried my brain working on other stuff today, and I could not do this faster. Or maybe if I knew JavaScript better, I could have written this replace statement a bit faster. All right, so again, that was a lot of random stuff. What did I do? I feel like a lot of these challenges is kind of about parsing the like understanding the problem. And once you understand the problem, you can do almost anything you want to solve it. So basically, it's saying there's this thing in this challenge, in this problem, that they call binary space partitioning, and it's basically saying if you take so let's do the rows, right? It has 128 rows labeled 0 to 127, and it's basically saying instead of telling you a number for your row, it's just going to tell you, okay, start in the middle and then either pick front or back. And then say it says front. So now stand in the middle of the front half and check the next letter. Oh, it's front again. So now stand in the middle of that front half and keep going until you reach your number. So you can see in the example, it says like F means to take the lower half. So you started at 0 to 127, and because it was F, you're now only at 0 to 63. Now, what that means though, right, is that is literally just binary numbers. Because in a binary number, you have your columns. What's a good way to write this out? You have your columns like this. Right? Your ones digit in your binary number is a 1. And then the next one is a... So if I had a binary number like this, let's say, right? The way this works in binary is that this is the number 1 plus 4 plus 8 plus 32, which is 30, 40, 45. This binary number is 45. I'm not going to be able to explain it any better. Anyway, so if you don't know binary, you're going to need to look it up yourself. But since it says F, the first letter means to decide whether you're taking rows 0 to 63 or rows 64 to 127. All we have to, that means F in the first column means add 0, and B in the first column means add 64, which means it's a binary number with this column, this digit in this column, with being 0 if it's F or 1 if it's B. And if you read through the example, that's exactly what it is doing for the entire number. And so to get the row number for your seat, all you have to do is convert all the F's to zeros or the B's to ones, and you will have a valid binary number that is equivalent to following this formula, except you don't have to actually write that out. So that was the row. And then if you read on, it says the same thing happens for the column, and that's pretty straightforward, right? The column is just R, L, R in this case. So R means the upper half, so R's are ones and L's are zeros. So you can see that 1, 0, 1 in binary is 4 plus 1, which is 5. And so that's the column. Now the trick here is that it says the unique seat ID is you multiply the row by 8, and then you add the column. Now if you know a little bit about, well, what's a good way to explain this? You see this 8 here? In decimal, right? This would be the equivalent of saying you take the row and you multiply it by 1,000. Let's say we had a 3-digit row in decimal and a 3-digit column in decimal and a 7-digit row in decimal as well. So the row is 1 to 1,000,000 and the column is 1 to 1,000. Then this statement here, this equation here, expression here, is equivalent to saying take the row, multiply it by 1,000, and then add the column. But then that's what we have already, right? We already have the row being stacked on top of the column. Oh, I can't explain this. Again, I suck at explaining this. The other way I want to explain this is through left shifts. how left shifting by 3 is the same as multiplying by 8, but I don't think that's helpful in any way, but maybe that helps. If that helps, you can see that if you just replace all the F's and all the L's with 0, and then all the B's and all the R's with 1, you end up with the unique seed ID down here, but with almost no work at all, right? All we had to do was exactly this line, this line here. Maybe we should explain what this says, but we'll start with this, right? Let me write this out so it's a little bit clearer. So we have the seat. What do they call it? That doesn't say. So we'll just call it the seat. I can't call it seat ID because that's something else. The seat code, let's call it. So const replaced binary string is you take the seat code and you replace all the F's and all the L's with a 0, and you replace all the B's and all the R's with a 1. So that gives us, oops, I got this wrong. And so that gives us, here, binary string will be a string in binary that is the seat ID already. And so all we have to do, once we have that, is we parse that binary string using the parseInt function, which we discovered yesterday, right? You have to tell it what base to parse a string in. So we didn't even have to write our own binary parsing function. We just have to say parseInt as a binary number by passing in 2 there, and then we return the seat ID. Now this input map is a functional programming concept. We have a list and it's all strings. What map is saying is take each of these values in this array as an input, run it through this function, take whatever comes out the other end, and return a new array with the results of running this function over each of the inputs individually. And so numbers at this point is an unsorted array of all the seats that we had in our input, which you can see in the bottom half of the screen there. And because it's unsorted, and we wanted, and the question asked us what was the greatest number, I sorted it in reverse order, and I logged up the first number, which would have given us the greatest number, 806. Some programming languages have a function called .max, which would do that for you. I don't think JavaScript has it, which was why I had to do the sort thing. You could fold, but folds in JavaScript are kind of, I don't even know if the syntax is right. It was too hard to work out on half a brain, so I just sorted it and printed the big number. That gave us the first number. That gave us the answer to the first half of the question. Now the second half of the question said that all the seats basically exist, but it starts at a random number and it ends at a random number, but we don't know what it is. And so what I did was, when I did this challenge, I basically asked the program for what was the biggest number and what was the smallest number. Now for the smallest number, what I did was I basically sorted it the other way around, and I got the smallest number. But we can do something like this to actually get it programmatically. So you can see we have 806 and 49 as our smallest and biggest numbers. But if we do it this way around, so we now have 0 is our smallest number, right? But the problem tells us that all the numbers are consecutive except for my seat, which is the missing one. Now I don't know what an efficient way to do that is, but what I basically decided to do was I'm just going to start from the first number. I know the number starts at 49. So I'm going to say the number at the beginning, right, the first number should be the index, which is 0, plus 49. The second number should be the index at 1 plus 49, and so on. And so I did that. That's what this 49 is. We could do this to make it programmatic. Until I find a number where it doesn't add up to it anymore. And if it doesn't add up to it anymore, then that means we skipped over the number that we should have found. But we would have, so the missing, we would come across the missing number really quickly. And the number we come across that is missing is, in this case, 562. 562 is missing, that is my seat. Yeah. Okay, I'm gonna stop the stream here because my brain is so fried, I can hear myself and know that I'm not explaining anything in any good detail. And so I will leave it there. It was a really cool challenge. I'm a little bit disappointed I didn't get a bit higher because this solution was so short and so elegant. But maybe next time I will have my full brain power available and I'll do a better job. But yeah, so until then, I will see you tomorrow.